Very good afternoon to you all. Today I will start the new topic. The topic is related to fluid dynamics and power in wind. Before to discuss this topic, uh, we have to know, I think we should know about the exact concept of fluid dynamics as well as power dynamics. If we state about the fluids at the uh, moving condition, and if the study is taking place and at that condition, and properties at that time will be considered as fluid dynamics, and the output form will be produced as a power. Thermodynamic variations, here in this slide you can see how the thermodynamic variation takes place. There are two main categories of turbo machines. Turbo machines, as if we see first point for the categories of turbo machines for the identification purpose. First point says that firstly those which absorb power increase the fluid pressure of head. Suppose that if you have to increase the fluid pressure or if you have to increase the head, then it means the energy would be absorbed at that place. And for to absorb power, there we have some devices like fans, compressors, and pumps. These devices are work consuming devices. Okay. For to perform a particular function, these devices will consume additional work. That's why such type of device is known as work consuming device, power consuming devices. Now, secondly, if we see the next thermodynamic variation, secondly, that produce power by expanding fluid to lower pressure or head. And these can be named as hydraulic, steam, as well as gas turbines. What is the main function of turbines? Actually, the turbine is a device that converts the fluid power into the mechanical power. In which form the fluid? We talk about the hydraulic machines. What is the main function of hydraulic machines? The hydraulic machines converts the water power of fluid into the shaft power in the form of mechanical form. Okay. Now, here is a table is drawn. It's having two parts. First one is incompressible fluid, and another one is compressible fluid. What does incompressible fluid says? Actually, incompressible fluid says, if we talk about the power generating machine, then incompressible fluid is used. Then that type of machine is known as hydraulic turbines. If we talk about the power consuming machines, and if incompressible fluid is used, then uh, which type of device will be used? And that device is pumps. Okay. Now, if we talk about the compressible fluid, it means the density of the fluid will change according to the time. And if that device is producing power, then that type of machine is known as power generating device. Okay. And if we see the example for the power generating machines, then power generating machines example are steam, gas, and well as wind turbine. It means you have to cover the topic related to power generating machines. In these three power generating machines, you have to clip here, means you have to know especially for wind turbines. All turbines having the same function, the main motive to generate mechanical power. If the working fluid is steam, then the turbine is known as steam turbine. If the working fluid is gas, then turbine is known as gas turbine. If the working fluid is wind, then the turbine is known as wind turbine. I think it should be clear to you all now. If we talk about the power consuming device for compressible fluid, then power consuming device in form of compressible fluid may be fan, blowers, compressor, etc. Now here, because your topic is fluid dynamics. What the fluid dynamics is? This is the turbo machine. Now here, this goes in turbo machine. Uh, at this section, some amount of energy will be at input, and some amount of energy would be at output for producing output. Here, from this section, the fluid would be entered with this whole entire section, and this whole entire section is a turbine machine. And further, after the after a process executed within the turbine machine, this fluid entered would be converted into the fluid output. Now here, I think diagram is not clear, but already discussed some of wind turbine in the form of vertical axis wind turbine. Now here, there are some wind turbine related to horizontal axis wind turbine. If the axis is allocated vertically, then that type of turbine, that type of wind turbine is known as vertical axis wind turbine. If the axis is allocated horizontally, then that type of wind turbine is known as horizontal axis wind turbine. There are some horizontal axis wind turbine, and these are very popular for power producing. Now, if we classify turbo machines, then there are two main categories of turbo machines which are identified. Firstly, those are jobs power to increase heat pressure or head. Example, fans, compressor, and pumps already discussed too. And secondly, this is power producing device. Now, the application of Euler's equation. Euler's equation applies to all type of turbo machines, as wind turbines, pumps, gas turbines, etc. The axial flow machines to radial flow to mixed flow. This is the sequence in which way the application takes place: axial flow, radial flow, mixed flow. When the radial as well as axial both exist, then finally these two flow will be named as single one, that is mixed flow. If we talk about the energy extraction machines, that is the energy consuming machine also. For a turbine, the value of equation is negative, as well as vice versa for the pump. Okay. Now here, in this case, finally we reached at that point for pumps, fans, blowers, and compressor. It is positive. Okay. Now here in this slide, you can see the Euler's work equation. This is the velocity function. The velocity component along the x-axis, or you can see the radial component of velocity, and along the x-axis unit vector is I. That's why this whole component is represented on the x-axis. Now, if we take a polar form, and it would be plotted on the y-axis. That's why v theta j is totally represented on along the y-axis. If we go along the z direction, then the velocity component is represented by vz j. Now whole summation is represented by the velocity vector over here. This one is v theta 2, this one. Total volume from that point, this point to this one, R1 to R2. Now the what does Euler theory see? The torque exerted by flow on plate room is equal to shaft output. Torque, the rate of change of angular momentum of flow. If we see in the whole work conversion in wind turbine, then the torque exerted by the flow on blade room, that is the shaft output torque, and it is the rate of change of angular momentum of flow. The next slide is related to the significance. What does significance say for the wind turbine? See, the significance of wind turbine may be understood under behalf of following points. First one is weather and climate. Next one is vehicles, automobiles, trains, ships, planes, environment, physiology, medicine, sports, recreation, many other examples are for the significance of wind turbine. If we talk about the analytical fluid dynamics, it may be approximate solution for the linear as well as empirical relations. Control volume differential analysis, exact solutions only exist for simple geometry and conditions. How many points may come under the category of fluid dynamics may be formulated by point-wise point. The first definition says that fluid statics, fluid in motion, continuity, momentum, energy principles, and last one you can see drag and lift, flow in continuous. Okay, drag and lift and the two forces play a very important role in wind turbine, and the last point will be discussed as a main topic of Unit 4 for the wind turbine in upcoming lectures. Now, if you are interested to for an overview, the basic equation of gas dynamics is equation of motion, mass conservation, equation of state. If we talk about the fundamental processes in a gas, then it may be classified as steady flows. If the property does not change according to time, then the flow comes under the category of steady flows. Self-gravitating wave phenomenon, shock explosions, etc. What are the applications? Isothermal spheres, special flows and drag forces, solar and stellar winds. These are the applications. Okay. If we want to differentiate classical mechanics versus fluid mechanics, classical mechanics deals with the single particles with a fixed mass, while the fluid mechanics deals with a continuum and a variable mass density. It circulates a single particle trajectory. It circulates a collection of flow lines. Single particles uses a position vector and velocity vector, while the fluid mechanics uses a field, mass density as well as velocity field. Now, the fourth point is very important. If we talk about the single particle, that we deals only with externally applied force. It means single particle mechanics जो है केवल externally applied force के लिए भी मतलब स्टडी की जाती है, और फ्लूइड मैकेनिक्स जो है डील्स विद इंटरनल एज वेल एज एक्सटर्नल फोर्सेस. formula related to the mass density, power density, etc. Suppose this fluid particles is going with the weak velocity, and for this particles, the small volume is represented by the delta V. If this molecules will be constituted, it will be considered as a molecular description, and its velocity will be represented by the V alpha. Here, you all know that the mass density as well as velocity may be defined as a ratio of density. If we consider the diagram, the mass density, suppose that mass delta n exists for the volume delta V, and if the mean velocity is V, then how it can define? We all know. We all know the mass density will be defined as the ratio of mass as well as volume occupied. Here the rho position x and time t, and delta nu, the viscosity tends to volume tends to 0. This denotes the mass density. And if we want to see a pictorial representation for equation of motion from Newton's to Navier Stokes, then here you can see the diagram for the fluid dynamics. The fluid dynamics is plotted on the x-axis. Now, single particle dynamics, from this formula you can see this local will be followed by the single particle dynamics, and this is the direction of velocity of the wind. And for the fluid dynamics, because the fluid particle exists in that case, that's why the streams line would be plotted more than once. You have to work with velocity field that depends on the position as well as time. Streamline with respect to time, it changes in x direction, z direction, y direction. In all those directions, the density is varying. Summation of the density at different points for different axes. If we sum up, then we will get the whole mass density. Finally, the summary it achieved these things, but you have to know what you have to find actually at this point a way to link the pressure to density and temperature, and a way to calculate how the density of the fluid changes. I think all the concepts are related to the fluid dynamics, and some remaining lectures will be covered in the upcoming video lectures. I think you have to collect more and more knowledge related to the fluid mechanics also. If any doubt is remaining, in this video lecture, then those would be resolved in the upcoming lectures. Okay. Thank you.